Hi everyone, my name is Fabrizio and today I will present the Spacelabs patient monitor model R-91390. My focus is on a key biomed function, so verifying the ECG LED placement, eventually evaluating ECG signal quality and performing essential electrical safety tests using the Fluke ESA 615. I will also demonstrate the grounding resistance measurement, the sachet leakage and the ECG LED leakage, and use the function of ESA 615 as an ECG simulator. So, why I choose this kind of device? I chose it because patients nowadays and in the patient monitoring is one of the most critical functions in healthcare. Among all the parameters displayed on the monitor, as we can see, the ECG on two lines, on two LEDs, the respiratory rate, the SpO2, the non-invasive blood pressure, for example. I wanted a topic that allow me to perform hands-on demonstration, show real troubleshooting scenarios and connect clinical words with the biomedical engineering responsibilities. This monitor also is widely used in the intensive care units, emergency departments and chirurgical setting, make it highly relevant for a biomed. The role of a biomed with this device is that we play an essential role ensuring that the patient monitors work safely and accurately. Our responsibilities include also to be preventive, with the preventive maintenance, replacing damages, ECG cables, for example, or sensors, verifying that the ECG is accurate and calibrated the unit and configuring all the alarm limits. So finally, we perform electrical safety tests according to the NFPA 99 and the IEC 60601 standards, like grounding resistance, sachet leakage, and patient LED leakage. All of these tasks ensure that both patients and clinicians remain safe while using the equipment. So let's go on the equipment. As we can see, overlooking it, we got the screen that is a completely touch screen where we have all the parameters, all the setting up bottom, and now with the light signal is saying to me, basically saying to us that something is missing, that is not reading a specific data. For this example is the ECG, and the nurse or the doctor can just press this button to set the alarm off. Just so I was saying before, I have set the alarms of the SpO2 at low 91, the saturation 85, and the alarm delay of 16 seconds. Here the nurses and doctors can fix them how they want. It depends about the patient. Okay, so basically I'm going to put my finger in it and it's reading, and now it should beeping because I should be over 91%. Noisy signal. Okay, here we go. High saturation alarm, and it's saying to me that I'm over the limit that I have just set it. So what is this device was created? So the Spacelabs R-91390 was designed to continuously monitor the vital sign like blood pressure in real time. So the goal is to detect the life-threatening changes, especially on the cardiac events before symptoms appear. Continuous ECG monitoring provides immediate alerts for arrhythmias, ischemia, and cardiac arrest. In critical care environments, even a few seconds of delayed section can be fatal. That's why the reliable ECG monitoring is really essential. So, how the ECG is working on the engineering side. So, to understand this kind of device, we need to look how ECG works from on an engineering perspective. So the heart produces electrical signal and in the range of microvolts. So this kind of signal are extremely small and easily affected by noise, as we will see later. So this monitor uses different things. So it's using differential amplifiers to eliminate the common mode noise, high pass filters to remove baseline wonder, and low pass filter to remove muscle noise, even that, and notch filter to eliminate the 60 Hz interference. And the last one is an analog to digital converters to digitize the signal. So understanding this engineering chain helps us to diagnosticate problems and ensure accurate readings. Let's go on the practical thing. So now I will demonstrate the ECG LED placement and the signal quality using the Spacelabs monitoring. We turn our ESA6015 on, and we can select from here. Nice. And as we can see on the monitor, here we go. Okay, you compare the specific QRS. What I mean? Okay. So for example, this is a complex of QRS. So, and that's a normal heart beating. What I can do with the ESA615 is to lower or increase the rate. So for example, let's see 120, and we can see over here that is going here. This will be 100, right? 120. I can change the waveform. For example, on a square wave, or this is a ventricular kind of ventricular fibrillation, or a triangle. So it's really helpful to set and to see if the signal is received. So also we got that the connections, the LEDs, maybe they are not connected well. So a loose electrode signal could be, for example, for the dry electrodes, because they have a really thin gel layer just between them and the skin. So they could be drier, or the poor skin contact can create lower quality signal. Biomet checked these issues during the troubleshooting. So let's pass to the electrical safety tests using the Fluke ESA615. These tests are required during the preventive maintenance to protect patients from electrical hazard. Grounding resistance tests verify that the monitor has a safe and low resistance path path to the ground. Okay, so as we can see, we have 0.36 and is passing, is below the 0.5. So that's the grounding test. This value is within acceptable range, meaning that the monitor is properly grounded. What we can do also is to measure the sachet enclosure. So it's the leaking test. So next, the sachet leakage test. This measures how much current leaks from the metal insured to the ground under the normal single fault conditions. Under normal condition, the leakage should be under about 100 micrograms. So we turn. Oh, it was not really connected well. It was moving. Okay. So we turn on the microamperes enclosure. Okay. What we need to see is that we need to check it with polarity normal and half close and half open. So basically, at half close we got 0.7, and at half open we have around 40. Let's see how if it's stable or not. Around 41 microamperes. Really below the 100 micrograms, as the NFPA 99 suggests. After sachet leakage, now we proceed to the ACG LED leakage. This is the most important test for the patient, for a patient monitor, because the ACG electrodes make direct contact with the patient's skin. So leakage through these leads must remain extremely low. Usually it's around from 10 to 15, usually 110, 50 microamps. So if the leakage increase, it's not only that can create some interference with the ECG reading, but also can affect the cardiac tissue. So with this device, it's really easy to measure it. Let's go. So here we got our device that is setting to give the ECG on our monitor, but basically we are going here, okay, to measure. Now we are on Earth. We want the leads one, so patient auxiliary, and now is selecting, for example, the RA. It's 1 microamps. Going with the arrow on the right, 1 amps for LL, 1 amps for LA, 1 amps for RN, and 0.1 per V1. Passing on the biggest safety risk with patient monitor include inaccurate ECG readings due to the damages leads, for example, excessive leakage current, and or alarm failures. So Spacelabs has had the FDA records in the past related to the software malfunctions, the arrhythmia detections issues, and which reinforce the importance of the regular med testing. The biggest safety risk with patient monitor include inaccurate ECG reading or due to the damaged leads, for example, or excessive leakage current, or of course alarm failures. So Spacelabs has had the FDA records in the past due to malfunction and due to software malfunctions and the arrhythmia detections issues. That's why it's really important and it's fundamentally in importance a regular biomed testing. In conclusion, the Spacelabs R-91390 is a vital device for continuous patient monitoring. As a biomed, we are responsible to verify ECG accuracy, ensuring proper leads replacement, troubleshooting noise and artifacts, and performing electrical safety tests with tools like the ESA 615, really easy to use and really important. And these steps just aim to guarantee reliable monitoring and safety and the patient safety. I hope you enjoyed this presentation. Thank you for watching. Have a great night.